Welcome to my next guide. This is to show how to easily set up a mapping mission with Mission Planner for ArduPlane and with auto takeoff and landing included. I've had to explain this quite a few times, so I thought it would be easier to make a directed webcast and or screencast rather, and then I think it will be even easier to understand with the demonstration. If you're doing mapping, you should be familiar with this screen, which is the Mission Planner, and we're going to skip the other stuff. We're just talking about making a mission, so we switch over to flight planning. Generally, this is where I fly, and we're going to use it as a demonstration. You would be advised to make the mission before you go to the site. I find it more difficult to plan the mission on a laptop, and you have a bigger screen probably at home on your computer and better internet for downloading all the stuff. So better do the mission there, and you can still modify slide bits on the site, or even upload at the site when you assemble the plane. Just make sure you have it on your laptop. So this is where I take off and land from. It's it's showing it as a home point, as you can see, but it doesn't need to be there. You could have your home wherever you are. We'll reset it there. It's very easy. And let's say we want to map this area just for the demonstration. You right click and select draw polygon, add a polygon point. It will tell you that until you leave the polygon mode, it will keep it in that. So there's one point, and you can add as many points as you like, and that's where it's going to start to create the grid for the mission. So let's put a point here. Let's try to map exactly this area because it's a nice shape that would demonstrate for us how nicely these polygons can work out in an area where we need to map. Okay, so we can move this by dragging, and so we have the area we need to map, which is this, and this is where we're going to launch from. Next, we have to select again the right click, and this time we go to auto waypoints and survey grid, the one, not the V2. Select it, and this comes up. We can zoom in, zoom out if we like. I'd like to talk about a little bit about this. There are quite a few things that could be relevant, although here you can just click OK, and it's already going to be a mapping mission, but it's better to configure it to suit our own needs perfectly. First of all, try clicking advanced options. And here I already have saved the camera that I'm going to use, which is the Sony A5100 and the 15mm Voigtlander lens. But if you didn't have it in the camera config, you can set up a camera, you set up the focal length, you can load a sample photo from the camera if you don't know what the camera can do. So focal length you set, and then from the photo it can derive the resolution of the picture and how many megapixels the sensor is. This is a 24 megapixel camera, and as with this, it will be able to calculate these things, which is what's important for it, which is the angle that the camera can see, and based on the altitude you're going to set up the mission, it can calculate the resolution you will have on the ground. The higher you go, the worse the resolution, obviously. So this page is just to set up the camera, and if you save, it will ask you to give it a name, and then next time you don't have to bother with this, and that's how I saved that camera I was using. So you better set one up for yourself. If you have that Sony, then these numbers are going to be correct for the sensor. Just adjust the focal length depending on the lens you're using, and save it whatever name you can or you want. This part you don't have to bother with, because we already have it saved, at least in my case, in the camera trigger setup of the mission planner, and it will be the thing to know. Just it should be on a trigger distance, and it's selected by default to breakup starts, and the mission will fill in the rest for us. The grid option, again, we should look at it, at least for first time, is distance between lines. We don't have to touch that. It will modify it by itself. We can ask it to start making the shots from home, or whichever, that is from the way we're coming in. In this case, we're flying in from this side, or it should start from a specific point of the polygon. That's up to us. I like to, and the overlap is key. Usually you'd say side overlap of 70-75%. It's good in the industry, from what I understand. I'm not very good at the whole processing or post-processing of the pictures is concerned. This means that each picture that is taken, the picture that will be taken next to it on the return leg, will be overlapped at this percentage. And practically, if we go up to 100, it means that there's no lines at all. The entire photo is overlapping the other photo. I think 70-75% is the usual standard. This will correct all the little deviations that they might have from being shot at two different angles. So they will have a very useful, very big area that is connected for the Pix 4D to process. And that's the side overlap. Front overlap, you're safe to make it 75%. This will not hinder performance in any way. This means that as it's going forward, it's going to fly there anyway, how often it will make the shots. The only thing to pay attention with this is depending on our platform, if the wind speed is very strong, the tail wind speed, and the camera, for example, can only shoot, in this case it's not a problem, but let's say the camera we're using can only shoot every 5 seconds, and the wind speed is 30 kilometers per hour, and our plane is flying because of the tailwind to maintain above stall speed. We're flying at 70 kilometers per hour, and we're only making shots every it can only shoot every 5 seconds. Then it will not be ready to make a picture, and it's already flown past the point where it's supposed to make a picture. I don't know how clear that is. So keep this between, again, 70-75. This is more than enough. In the side overlapping, one would say the higher the better. Yes, 90% overlap is much better than 70% overlap. The problem is, the more we increase this, the more lines, and here you can see the distance that needs to be flown of the plane, because it has to fly much more, and that's an issue with huge areas. If you go up to, let's say, something crazy like 90% overlap, where we're going for 30 kilometers flight compared to 70% overlap, which is only 10 kilometers. So it's a huge difference. That's why we don't go crazy with this. Some might even try to bring it down to 60, but we're using a wide angle lens, and the vignetting of the pictures would have a bad effect if you go lower than this. The lane waypoint, not interesting, and the distance is showing us based on the overlap. Again, you can see that if we make 70% overlap to the side and 70% forward, then it's going to want to make a picture every 37 meters. Now we can go back to what I was saying, that for example, in this plane's case, it's flying at about 48-50 kilometers per hour, maybe sometimes even 43, and this camera can make a shot every 2 seconds. So that's about 13, I think it's about 13 meters per second, and we divide that with this. That means it's going to get to every waypoint about 3-4 seconds, around 3 seconds. So if we made this much lower and made this much lower, then it will not be able to cope with the instances at which it needs to make the pictures. Maybe it was unnecessary to explain this part. Might sound much more confusing than is needed, but I think it's good to have an understanding of what limitations we should be aware of generally. Okay, so that's settled. The camera is configured. We already had that saved. So if we saved it, the next time we don't need to go into this. We just check this, and also the grid options should be carried over for next time. The overlapping would be remembered, and then we don't need to go into the advanced, but we can always verify. So we select the camera we had saved for ourselves, and here two things that are key. Okay, one, you can look at the footprints with the overlapping. We have to zoom in to see that. These little squares are what the picture would be taking, and as the pictures show here, you can see how much the overlaps are happening. But this is it's really tight, so I'm not sure how well you can see it. Anyway, we move that to make it look cleaner. One of the things we need to decide is the resolution we need. It will always calculate and show ground resolution here. And to change this, the simple thing we need to change is the altitude. The higher we go, the worse the resolution becomes. From what I understand, again, industry standards for most mapping is about just below 5 centimeters or 5 centimeters per pixel. That means every pixel on the picture will represent 5 centimeters on the ground. For some general mapping, you can go much higher. Why would you want to go higher? Because the higher you go, again, the less distance we have to fly. So now we are at 7 centimeters, which is, again, very good for a lot of stuff. And we only need to fly 3.6 kilometers. On a small scale, this doesn't matter. But when you have 10 square kilometers to map, then we're talking of huge differences. I might show you that if we want to map 10 square kilometers, so 10 kilometers by 10, like 2 by 5 kilometers, then this could go up to 100 kilometers. Depending on what resolution we see, and few planes can fly 100 kilometers. Mine can, but not a lot of them can do that. So this is why this is relevant. We should always go for whatever is the acceptable level that is needed. Going much below that on a big mission would just hinder efficiency and make you need to fly a lot. Let's say our plane can only fly 5 kilometers, then this type of resolution is already giving us 8 kilometers, so we need to know what our limit is. Now we're at 4.9 kilometers. So what you need, and go for that altitude that will give you. This is a very wide angle lens, 50 millimeters, so it's very good for efficient, long, huge area mapping. As you can see, it's at 190 meters AGL is going to give us 4.94 centimeters resolution. Most cameras would be much narrower, so would need to have a lower flight to cover an area. Also, of course, the pixel density comes into question too. It's also showing us the distance between the images would be 49 meters. The area we're covering here is also given, square meters, and how long it will take based on the speed where the platform that we selected. But it will just give an estimate of normal flight. It will take us a little less than 10 minutes to complete the mission. The footprints, the general summary data. And here you can decide if you want to override the cruise speed of the plane. You want to go higher than the cruise speed because you're in a rush. You can make a higher, in this case the cruise speed is set to 43 kilometers per hour. You can set it to 50, and say for this mission it should adjust the speed to this while it's flying, because you want to do it at this speed, and it will then use that. And finally, so we discussed the altitude. The other important thing is the angle. Most people don't touch this, and I think it's key. This is relevant in respect of the wind direction. This is north, obviously, and the wind could be coming in any direction. You should be able to know, even if you don't have good weather reports in your area, when you're out flying, you should be able to check the wind direction at the site, and then you can still adjust this before uploading to your PixHawk. So whatever the wind direction is, for easier reference, let's say it's blowing from the north, so coming from the north to the south. Always try to be to the side of the wind. You might find this not logical. Why would you want side wind? That will throw the plane. We're not talking of gusts, we're talking of more or less steady winds. But in fact, our UAV is very good at handling even gust and side winds, so it will not be pushed. It can fly in up to 45-50 kilometers side wind, so that's not an issue. Why you want to adjust the wind to be to the side of the plane is because then it will not hinder the flight speed. If, for say, and as you change this, you're going to be changing the flight path, as you can see. So let's say we went to fly like this, and we are having a rather strong headwind from north. That means that when it's flying to north, it's not a problem. It will use the throttle to increase the airspeed to get to wherever it's going. But when it's flying back, it's going to be getting a lot of speed from the wind, and no matter how slow it flies, it needs to maintain the above stall airspeed. So that means in our case with 50, let's go for something extreme, with 50 kilometers per hour wind from the north, and the plane would be needing about 40 kilometers per hour to fly a level for above 40. That means we're going to be flying at 90 kilometers per hour. So it might not be able to make the pictures at every waypoint that is needed to. It will be going so fast the camera might not be able to reset. And this is the reason why generally it's advised to always stay at 90 degrees perpendicular to the wind direction. It doesn't matter if it's right to left or left or right. So in this case, if the wind is coming north, just roll this to whichever side to be perpendicular to the wind. So that's it. Or you could do the other way around. It doesn't matter. Just make sure it's 90-degree angle to the wind direction. One of these options is to add auto takeoff and land waypoints. Use RTL. This means that if we take auto takeoff and land, that means wherever now it thinks the home is here. We can always change this ourselves, but how you can insert a home point even if you're not there by right clicking and put home here. I'll show that in a bit if you didn't know it. And what it will do is it will add in the mission lines, because there will be a lot of command lines for every single picture, every waypoint, every camera triggering. It will add at the beginning of the line a takeoff command, and at the end of the line a landing command. And then all you need to do is more or less adjust where you want the landing to be. Takeoff doesn't matter, and this is one point I'll explain how takeoff works. Takeoff is not a waypoint. Takeoff is just a command, and it doesn't care about where you are. It's just a command that does exactly one thing. So let's say we add takeoff and landing waypoint from the base. So we see the commands here. Let's see, 44 commands. And the first is landing, takeoff, and the last one is landing. In between, you have change speed, as we had in this mission. To change the speed, then we have the first waypoint going here, and that's number 3, and then going here, going this way, and zigzagging all the way. We have the camera snapshots at each point where it needs to trigger, and we have the waypoints for the zigzagging. that's a mission. Now we can go and fly almost, except if we want to auto land, then we have to take wind direction into consideration, and also take into the consideration where there's a tree, because you should understand that Mission Planner and PICSOC and the whole Aju pilot scene is dominated by quads, so they don't care about landing strips. They just come home and land. They can land on your feet. They're multi-rotors. But for fixed wings, you cannot just land anywhere. You need to plan it well. So in our case, we need to do that before we set on this mission. Otherwise, this plane would just come in and try to land here, even if right before it there's a big tree or a heap or whatever. Takeoff is much easier. Takeoff command has two parameters only. One of them is, and for you to see a parameter of a particular waypoint, this is one thing again people have been confused in. When you select something, then it will show parameters for that. This way is distance, and these ones are all the same. The let, and here you have angles. In this case, we're doing a camera triggering, so all it needs is a command, how much distance the plane needs to fly from the waypoint before it and the waypoint after it, and every 49 meters it will trigger. That's all the command does. So in this case it's a distance. When we select a waypoint, you can see distance disappeared. What did appear was the altitude, which is 190, longitude, latitude for the waypoint. And this is just calculated again. It is showing the distance between the last one and the next one, and calculated fields like that. Gradient is 0 because it's not changing the altitude. Those are the same. Next, why I wanted to explain this is for you to see the two parameters for the takeoff, you have to select the takeoff, and here are the two parameters. By default, it does 20. This is the pitch angle. This is the angle that we want the plane to take off or try to take off when we're throwing it out of our hands. And this is the altitude at which where we want the takeoff to get to. So takeoff command, all it does is when you switch on the auto mode, it will spin up the props. It doesn't care if you throw it in this direction or this direction or this direction. Where do we throw it? We throw it into the wind. So let's say we're still staying with the north wind. We throw it in this direction. That means what it will do is when we throw it, it will lock the heading in the direction that we made it throw, and it will give full power and try to go to 20 meters pitch up, and it will continue doing that is flying up until it gets to 30 meters altitude. No, we didn't want this. Until it gets to 30 meters altitude. I wanted to show this. This is a forest or a line of trees here. Let's say that we have a very low pitch, or these trees are incredibly high and this is a very short distance. Then this plane will start to fly and climb and try to get to 30 meters altitude. If it's supposed to get to 30 meters altitude here and these trees are lower, then it will hit the trees. It wouldn't know. So pay attention to anything very close around. Try to launch in a direction that it has a lot of space. In reality, a lot of space means 50 meters because it can really climb high. Even I generally like to go for around 50 degrees for the pitch angle, and that's already strong climbing. And you can calculate from that with 15 degrees pitch, how far out, let's say at 50 meters, it will already be higher than most of the trees that you would find in your area, depending on your area. If it's the Amazonas jungle, then we'd need more space and maybe a higher pitch. So say we go for 15, but you can go for the 20 and then set altitude. Set this altitude to a point where it's going to be safe for anything in the immediate vicinity. I would say there are very few trees that are above 40 meters. I like to set it to 50. That means it's going to continue here until it goes to 50 meters, and then what it does, until then it will not do anything else. It will fly straight, lock the heading till it gets to 50, and only as it reaches 50, And 50 could be here, it could be here. It doesn't care. It's just going straight. When it reaches 50, then it will go to the next waypoint. In this case, it will do speed to 13 meters per second, and then the third, it will see a waypoint around here, and it will start flying to it. So even though you see the line going, sorry, the dotted line going this way, and this is why it's a dotted line for takeoff, is because it's not going to actually go this way. It's going to go wherever you throw it. So if we throw it here, it will fly here, get to 50 meters, and then it will start engaging to hit this waypoint in reality. But you could actually do it backwards. Let's say the wind is coming from the west. That means you throw it this way, it will fly, to keep flying until it gets to 50 meters AGL, then it will turn back completely and start going. Same this way. And if we're lucky in this case of this mission and the wind is coming from the east, then throw it in this direction, then it won't need to fly any other place. It will keep flying here in the direction you threw it, 50 meters AGL, and then from the 50 meters, once it's hit, it will go to next waypoint and start heading to this number 3, as we can see here. I hope that makes sense. That's for takeoff. It's the easier one. Really, it's just one command. It's not easy to mess it up because we just have an angle and an altitude. So make a safe altitude for the vicinity. Why I say this is important, because you could just set 10 meters and it will be fine. It's not going to hit the ground. To climb to 10 meters and then engage the waypoint. But let's say our home is here. Okay, this will, let me set. I promised you I'll show you the home. Where is it? I think while we're it's not showing all the time. Anyway, okay, we have one on the field. Sorry, I dragged the wrong one. We'll take the home. This is the last waypoint. So let's say this is our home, and or maybe here, just to make it more realistic. So this is where we are at home, and we have the north wind, and we set 10 meters for altitude after takeoff, and we throw it into the wind. I think I would say about here it's going to definitely be at 10 meters AGL. 10 meters is very low. Then what is it going to do at 10 meters? It's going to start heading for the first waypoint. Our first waypoint is at quite a safe altitude of 190 meters, but it's not going to jump to 190 here. It cannot. It's not a helicopter. It's going to start flying and slowly going, as you can see it with this gradient and 14 degree angle. It's going to start going with 14 degree angle towards the waypoint. Let me get even closer to this. Yeah, here is better. No. Okay, we'll stay here. I need the tree line to be in the way. So we throw it 10 meters, it will start flying. When it starts flying this way, it will still be very low, and it will be low for quite a while because there's a lot of distance. There's almost 500 meters distance between this point and the first waypoint. That means it will maybe be at 15 meters when it gets to this tree line, and it will crash into the trees. So this is the reason why we specify a safe altitude, so that no matter where it reaches this point, it will be at 50 meters, and there will be anywhere it starts to come from. Even if it starts from here, 50 meters will be way over these trees that we can see on the picture. So that's the takeoff. Again, difficult to mess it up, just very few things to pay attention to. Actually, just direction. If you have these two numbers set up, this is of course for the plane, but you can set it to 20. It will try to do 20. I don't think there's a reason, unless you have you are in a very tight place and you need it to climb extremely fast. Otherwise, 15 is perfectly fine. And put a safe altitude. 50 meters will have you covered in almost any part of the world. There are very few trees that are over 50 meters high, and that's it about takeoff. Now the landing is where we need to think a bit more. about what we're doing. It added a landing, and I explained this landing is not something that it thought about. It just added it as a landing for a multi-rotor. Come here and land. Although it knows that it's a plane, because for the landing it gave the altitude of 0, so it's going to try to climb from 190 to 0 between the last waypoint and the point of the landing. And you can see here the angle. It's calculated that it's going to need to come to. Now this would be in this case not ideal. Number one is the wind direction. We said the wind is coming from the north. We always need to be landing into the wind as much as possible, except if it's just impossible because we have a corridor that's not in that direction. But as much as possible, we should come into the wind. It will give us softer landing, and there will be less overshooting, because the plane can fly fast if it wants to, but it cannot fly slow if it wants to. The minimum speed is always something that needs to be above the stall speed. Maximum speed is more limitless. I say limitless in that you'll hardly be flying 100 km/h wind. So let's say from 0 to 50 km/h wind, it can adjust the throttle and go against that, because it can fly 100 km/h if it needs to. So it will just adjust a little bit above that, and it will be safe and come in with that. So we want the runway virtually to be, we want the plane to come in here this way and then land this way. Let's say, okay, let's use this road as if it was a landing strip. It's very small, so it's not really ideal for that, but just to show you the marking. So the wind is coming from the north, and we want to land here, and this is where we would like the landing to be. So first up, we can put the waypoint to exactly where we would prefer the plane to touch down, because that's what it will calculate, to try to touch down at that point. Of course, if there's tailwind, it will carry it more than that point. If there's a front wind, so many little things can move it back and forth, but it's quite good at maintaining the side, that is the line to be at this point. It's not going to start landing here. As long as the GPS is accurate, it will try to maintain that line for coming in. How do we tell it to come in at the line? Because you cannot say land here. You just have a point to land here. Very simple. You give it a waypoint that is the last waypoint before coming in, and it will go straight in that waypoint. So in this case, we can say add a waypoint. Okay, we're still in polygon mode, sorry. That waypoint, you say insert waypoint here. So it's going to be waypoint 44. And be mindful that it will always add to the next point, and we want this to be before the landing. So we go up one, and now the waypoint is just before the landing. So what will happen now is when the mission is finished, the last one, instead of flying here, it's going to fly to this waypoint. And as you can see, the waypoint is almost as if it's coming in on the road for the landing. So what it will do now is come to this waypoint, then turn this way and come in here and try to land. So that's one of the basics. Now what we need to decide, of course, check if there are trees here that it could hit. There are none, because I know, but if in case there are trees here, then this would not be a good idea. Or you have to always consider avoiding the trees. For example, this last waypoint in our case is 100 meters, and say there's a tree line here, and it's higher than also, sorry, yeah, you can see the angle that is coming into is incredibly steep. This is a 28-degree angle. That is so much speed, because it's a heavy plane. So when it's coming in with so much speed, there's no way it's going to stop here. It will overshoot like to this place, because once it flares, the speed will translate and into the momentum, and it will be flying too fast to be able to touch down here at this angle. It cannot slow itself, as I told you again, no air brakes. We need this to be, ideally, this angle under 10 degrees. That's more or less okay, because the plane glides at about between 5 and 6, so something between 7 and 10 degrees is good. That means it will not need to use much propeller as long as the wind is steady, there's no wind, and it's still not going to carry too much speed, but still maintain the airspeed. So between 7 and 10, how do we get this lower? That means we have to reduce the altitude of the last waypoint. We have to keep coming down with this waypoint, let's say something like 60 meters, and you can see the angle comes down. No, we need lower. Let's go 40, still too high. This is AGL 40, AGL 0. So between the two, there's a triangle, and that's the angle we're talking about. So go to 30, yeah, that's more like it. Actually, luckily, this is a barren place, so I can go down to 20 if I wanted to, and I know it will not hit anything. Let's say 25. So I like 25, 7.7 degree angle from here to here. Or I could say 20 and get it a little closer. We can also change the angle with that, just so you know. Or get it further away. As you can see, if I go further, it's going to reduce the angle. If I go forward, so let's say we have an exact 7 degree angle there, and we're at 20 meters altitude. You can add as many waypoints as you want. We could do something like this. We could say add waypoint 44 and switch this to up. Okay, so we can make it like this. The plane will come from here so that it doesn't have to suddenly reduce altitude. It can come from the last waypoint, which is 190, come down to 100, and then from 100 to 20, we have another very high speed flight. So we reduce this to something like 70, and then even lower, 60. Yeah, we go something like that, and then push it a little bit further out. Yeah, so now it will come into here, make a turn, keep going down. It will. The thing with the waypoints is you can set up as much as you want. It's a good guiding system to how you want to approach the whole situation. So for example, if you have a terrain, let me try to draw this. If you have like a base like this, now I'm drawing from profile, and there's trees here, and there's a very tall tree, and you want to land here. What you have to make sure of is all the waypoints maintain at least to this point. So keep the last waypoint above the last tree line, and only from there to come down here. Now in case this angle is too steep, we could do something like make a waypoint here which is lower, and then make one here. I don't know if you get the point. So come in here with whatever you're coming with, will matter. Then the next waypoint way before this one, so that while it's on the way here, you can try to reduce speed. Otherwise, it will overshoot too much. So make a waypoint that's definitely above the tree line. Make a lot of, the barometer and the plane can drift. So make sure there's 20 plus meters between the last thing that you know, the height, and your plane. It has happened before that we got stuck in a tree because of 5 meters drift in the barometer, and got caught up in a tree because it was too close. So make 20 plus meters, and then come down, because here you're free, come down to wherever you need to be. Alright, let's go on with the planning of the landing. It's much easier when you know what you're doing. I need to describe in detail each of the things so you understand what's happening. Again, I'm in the wrong mode. Okay, so back to the landing. It's getting to be a long video. I thought it would be something simple to explain. I tend to over-explain stuff. Better safe than sorry, right? And one more thing we need to add. So basically here we have a landing. The plane will come from the last known waypoint to the last waypoint and the landing point. It will take the landing practically. It will treat it like a waypoint. It will try to fly to it. At this point, if we don't have a LiDAR installed in your system and maybe reverse thrusting, it could really be here, it could be here. It really depends on how much wind there is, and the weather and the plane and a lot of things. So always make sure you have free space, at least before. I would say the whole area should have at least free space for 50 meters before and after to be safe. Then you can be sure that it's not going to land. Like if you had don't plan this landing point and have 20 meters after that have a brick wall, because it could fly into the brick wall. Just make sure there's enough space, 100 meter space for landing, and try to hit it to be at the middle. There are ways to evade the landing, which we can talk about in case you see, because you're going to be standing next to it. You'll see how it's going, and if you see at this point it's still 2 meters above the ground, then you know it's going to really overshoot. So you can avoid avoid the brick wall, as I said. All right. So try to land in a safe place, and of course into the wind. As we're landing into the wind, it will have an easier time getting to exactly that point. If everything was ideal, the approach angle and the weather, then it would touch down at this point, but it's never really ideal. There's always some wind. The approach angle and the glide angle is never exactly the same. A lot depends on your how much above sea level you are for the plane's flight, and a few other things. If you have a LiDAR, then the altitude sense, of course, so the barometer drift also, when it thinks that it's 10 meters high, when it's not actually 10 meters high. With a LiDAR, it will always be very aware of exactly how high it is above the ground. All right, so that's for the landing. I think the basics are covered. The two things I would add, one is we can set up that in case of any kind of failure, return to launch. It would return to launch and also engage auto landing, and it will use the same landing that we set up here. For this, we need to do two things. In the parameters, we need to enable a parameter that will it will check whenever it's engaging return to launch. If we set it to 1, then it will go for auto land. Here what we need to do is add another waypoint like this. It's not actually going to be a waypoint. We're going to remove it. But first, what we have to select, we have to rename the command to 44. Do land start. Yeah. So this thing called do land start is going to be number 55. Yeah. So do land start is what command it will look for if we have set up. I think I'll move it one more step up. So wherever the plane is, if we engage return to launch and we have the parameter, which I usually set enabled in the settings of the ADRU plane, then no matter where it is, it will go through the commands till it finds this do land start, and it will try to do everything above the do land start. That is, even if it's around here and we engage RTL, or we have a failsafe and the failsafe is set to return to launch also, it will jump to this. So it will go from there, it will look for the next command right after do land start, which is this, then it will fly to this, then it will land. So I recommend always adding this do land start to the landing, because anything can happen on the field. Imagine our remote control exploded. Very rare, of course, but let's say it just fails and there's no way it can reconnect. Then most normally it will return to launch and it will start circling over the base at 100 meters altitude or whatever. And we have to wait there for hours until the battery dies. Then it will keep falling down and probably hit a tree, you know, if we're lucky. And with this, the plane will come and land, not just circle at the designated landing point. So it makes much more sense to have this engaged for a fail-safe or any kind of problems, that right after the mission, or we're here and we get a call that, or get attacked by a bear, I usually say that, and we have to run away, the plane will not keep circling there. It will come in and land, no matter what, and we know the plane is going to be there at the end of the mission, or in case of a fail-safe or whatever happens. So it's always good to have this input here. And for the final point, we still need one more point, because it is designed that way. We add a command, another waypoint, we're still in this mode, insert waypoint here, that's this one, and we change this to RTL. So it has an RTL at the end of the return to launch. This is for a few things. This is for in case the landing is aborted, or it doesn't initiate the landing, or it senses something happened to the landing. Next command should be the return to launch. This is at 48. Yeah, it doesn't have a waypoint, so that's it. So for any reason this does not happen, it doesn't do the landing, it feels it didn't find ground, it aborted, anything, then it will default to return to launch. That means whatever is set up for return to launch, which is circling overhead, is still safer than for it to fly away, as you can imagine. So this is your basic mission. Take off, do the mission, come in the approach that we designed, and land. I hope that is clear. Just put do land start to wherever we start. It's not a waypoint. You can see it's not there. It's not showing. This is 60 meters. Sorry, this is waypoint 45. So that's waypoint 45, and the one before it is 43. Where is it? Somewhere. It should be somewhere here. 45. Yeah, because of the camera. So do land start 45, and then first the waypoint before it is 41 here. So you see there's no waypoints in between. These are commands, not waypoints. So do land start is not a waypoint. Don't put it here, because it will want to come. It will want to come here and just land. You know, it's not going to put it between the first. Put it before the first approach point. I like to call it the landing approach. So this is our first landing approach waypoint. 1, 2, land. So you have to put it before the first landing approach. So no, even if it's starting from here, it will come here first and then come into land. It should always come into land. So use these waypoints to direct the plane path, and most importantly the altitude, as I showed that you want it to come in at a good altitude for you for the area. Make sure that this one or this one is still above whatever because if you had a landing from here to here, even if the wind direction was correct, it means it will start coming down very gradually, and if there's any obstacles here, it's going to hit it. So with these waypoints we can guarantee that it's going to be above whatever is in between, and also the approach path. So now we have a mission, we save it to the computer, and then we can when we're connected to the plane, the UAV, then we write the waypoints. Okay, this is a 50-minute tutorial. It's just too long for what it does. I hope you have the patience to listen to it, and I have to make more effort in shortening the explanation for the things that I talk about. So feel free to contact me or call me if you have any questions and something is not clear. That's basically that's basically all you need to do for a mission. The rest is after the mission, how to get the pictures, geotag and process, but that's not my cup of tea. The flying is more what it is. Thank you for your audience, and bye bye.